Everybody's going to see who's going to do it, right?
Woof, whoa. Ruff, ruff. Come on. Come on. Get in on it. You're down in Mexico. What kind of sound do they make down in Mexico for that?
It's wow, wow. Wow,
Wow,
wow.
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 So what's the theme of today's show? On the
I have
Charles?
no idea, but we're live, and welcome back to Corona Geek, where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever, and today we're making international dog sounds.
Barking plugin for Corona SDK that can bark in different languages.
Oh, there you go. That'd be cool. Yeah, it'd be what do you call that?
I can communicate with dogs around the world.
Exactly. You wouldn't even have to worry about it. It'd be all
Well,
right.
not really communicate, more like piss off all dogs around.
Okay. I can get bitten in more than one country.
Well, joining us today is we got Ed Maurina here from RoamingGamer.com. We have Sergey Lerg from SpiralCodeStudio.com, and we've got Steven Johnson with us from VisualBossStudios.com.
Zibalba.
So we've got a lot of stuff to talk about today. We've been doing a series of videos on a game that's a popular game that's already been created. It kind of it's called They Need to Be Fed 3. And if you haven't watched these videos, you need to go over to youtube.com/coronageek and watch the videos there. They're all labeled Part 1, Part 2, Part 3, and so on. And last time we added turrets to the mix, and we also had heat-seeking bullets. What I'm calling heat-seeking bullets. I don't know. What do you call them, Ed? They're just
guided missiles.
Guided missiles, heat-seeking.
Yeah,
Is it guided missiles or homing missiles?
Homing.
Oh yeah, homing missiles. Yeah. So they chase the player around the platform, which in this case is a circle, and it's actually pretty comical to watch when you're running away from these things.
When
it
you
looks like
get
a cartoon.
caught with two chasing you, you get kind of in trouble. You're like, you can't decide where to go.
Yeah. Well, the last time we talked about the vector math involved and looked at some of the code and stuff, but I think we want to slow down a little bit, maybe back up just a few steps to just make sure that everybody understands all the different moving parts so that we don't just sort of wave our hands and say, oh yeah, vector math is involved, and kind of move on and leave anybody behind. So we're going to slow down a little bit this time and cover some of the details. Before we get to that, though, I do have a topic that I kind of want to raise, and that is ad blockers. I don't know if you guys have.
Well, I've been following that a little bit, yeah.
Have you? So iOS 9 allows now for you to install an ad blocker. And I don't know, what's that?
In Safari.
Yeah, in Safari, right? So yeah, so what you do is you go out and purchase your ad blocker, and then that ad blocker has instructions for enabling that feature on your device. And then when you open up Safari and go to any site, the ads are just blocked. And so I saw this being talked about, but didn't really pay much attention to it, which I think is maybe the case for most people. And but then I saw this article come across the wire that piqued my curiosity, and so I got to reading up on it, and I went to the store and I saw that there were a couple of plugins that were really the top plugins, and one of them was called Peace by Marco Arment, who is pretty sort of pretty, I guess, internet famous, if you will, and then the other one was Crystal. And I got to looking at who the developer of Crystal was, and I realized it was Dean Murphy. You guys remember Dean Murphy, right?
Yeah.
Yeah, Corona developer, been on the show before, been on the panel before. Lots of great tips and advice from him and stuff. Well, he's doing iOS development now, and he created Crystal. And
striking when the camera's hot.
What's that? Yeah, exactly. Yeah, I was really surprised, and I'm very proud of him for like jumping on this thing. Well, anyway, he's going to be on the show next week to talk about ad blockers and kind of like the journey that he's been on, and to add sort of a curiosity piece to the mix, or just a sort of an element of drama, I guess you could say, is that Marco Arment, the developer of Peace, which was the #1 ad blocker up until a couple of days ago, he actually pulled the ad blocker from the store, and which leaves Dean as the #1 ad blocker in the store. So
that never hurts.
Awesome.
yeah. So congratulations to Dean, and we're very proud of him. And he's going to come on and talk to us about the whole thing. So that'll be next week. He'll be our guest for next week. So I'm really excited about that. But I just wanted to put this out to the panel. Are you guys interested in ad blockers for your device? Do you have any kind of?
You know my answer, buddy.
Ed, you don't have a device. Okay, I'm sorry.
It's my device. I can shut off the ads anytime.
I suppose Android already supports some ad blocking, but I never cared to install it.
Yeah. Well, I'm sure. Yeah, and I'm sure that you can probably get an Android blocker, but this, at least according to the articles out there, this seems to be sort of I don't know, kind of fly in the face of Apple flying in the face of Google, right? Because we all know that Google gets their ad revenue from ads, or they get their ad revenue from ads. Yeah, that makes sense. They get all the majority of their revenue from ads, and for Apple to sort of say, "Hey, we're going to allow people to block ads on their on Safari," really kind of should get up their nose quite a bit. I don't know. Anyway,
that's what I was reading in the articles. Is that it's kind of like striking at Google.
Yeah, and you have to kind of break it down, I guess, and we'll talk more about this next week. But Apple is a portion of the market, and then there's Android, and of course, Android. I mean, Google. Let's just say Google is not going to implement an ad blocker, right? They're not going to really encourage people to put in ad blockers. At least I don't think. And so that really means that half of the market will still be seeing ads. So, and on iOS, only the percentage of people who actually go to the trouble of installing an ad blocker will be blocking ads. But I think it's gonna. I don't know. From what I've seen, Dean's listing had 450 positive reviews. Like 4.5, 5 stars. So we all know that that's just a portion. People who leave reviews are only a small portion of the people who actually purchase an ad blocker, right? So I can imagine that this is a lot more popular than we think.
Golden goose.
Yeah, I think this is a lot more popular than we think, and desktop blockers are becoming very popular. I mean, at least the conversation around them are becoming very popular. I hear a lot of. I've heard a lot more.
What can I tell you about ad block on my browser is the life without it is just terrifying, because you make one wrong click and you go to the hell of ad banners page, so it's disaster.
Yeah. Well, I know that just in general, from a user experience standpoint, that websites load faster. And one of the stated benefits for mobile is that the pages load faster. 2, they don't take up as much bandwidth off of your data plan. And 3, you're not engaging the radio as much to try to download content, so you're actually getting more battery life out of your battery, or more charge time out of your battery, because you're not having to spend it all engaging the radio to make all these extra calls. So anyway, it's some interesting stuff. Here, I was going to put a link in here. So if you go to iOS and search for ad blockers, he'll probably come up anyway. But Crystal is the name of it. So we'll put a link in the show notes to it, and I put a link in the chat here to a post that he did back in August? In August 22nd, he did some benchmarks for Crystal and showed some of the load times and things like that. So just some interesting numbers there for sure.
I just wanted to add to your announcement here is that this is probably the only time I've ever seen this where 2 members of the Corona community now have their apps in a top 10 slot somewhere on one of the 3 columns of the App Annie. So Pop the
nice.
Lock is still toggling between first and second. And Crystal, of course, as you were just saying, is number 1 now and paid.
Yeah. So that's great. That is great. Yeah, of course, Crystal's not, Crystal's iOS, right? Just, straight iOS, not Corona. But,
well, yeah, but he's part of the community. That's what I'm saying.
Right. Part of, I still consider Dean part of the community.
Yeah, no, I wasn't saying this was written with Corona.
Oh yeah, I just want to make sure to clarify for anybody. Yeah, people are like, hey, cool.
Well, you know what? I wonder though, why couldn't you write it with Corona if you did it with Enterprise?
Yeah, yeah, exactly. I'm sure you could.
I don't know exactly what's going on in the background there, but what do we got available to us, Sergey? We got C#. We got what else we got available in the native land for Enterprise?
C# is for Microsoft. We have Java and Objective-C.
Oh, Java.
And I believe we can also use Swift for plugins.
Have you done any Swift plugins yet?
No, but I don't know. I have kind of streamlined my process with Objective-C, so it's not a problem for me to do it in Objective-C, and it's faster, so it's obviously a plus for a plugin to work faster.
I get them all.
I have been learning some C# recently, but not for Windows development. But how to put it? I had an opportunity to revisit Unity and to see what's happening there, and they use C#.
Yeah, they do.
I'm really glad to see C# has taken off over the years the way it has. It really wasn't clear in the beginning. Microsoft was going to open source the language, and you're kind of like, well, can that mean that it would take off on its own, right? It would have a life of its own, and it has, and that's really great. I wonder, I'm curious if whether or not Swift will do the same thing.
I think
to become open source.
No.
Yeah. Well, Apple is going to, open source or has open source. I don't remember the timeline on that, but they said they were going to open source Swift.
I can't see how it wouldn't, because it was immensely popular when it first came out and it was closed.
Swift might become popular if it would be available to write Android apps as well with Swift.
But there's talk of that too. In fact, isn't there already? I thought somebody had already done some work on that. Like a Swift variation for Android or a Swift something for Android.
Swift will become open source, but there's no timeline yet.
Okay. Wouldn't that just chap Google? I mean, maybe they'd be happy with it, right? Because then more people it would be easier or whatever. People, be more unified in developing apps. But I don't know. I just think if I might chap Google to be like, they'll kind of lose control. People start developing Swift apps for Android.
I don't know. I'd like to see a unified landscape for development.
Oh yeah. Oh, most definitely. Yeah. I mean, to be just having to learn multiple languages. I mean, that's the whole basis for Corona, right? Is that you don't have to learn multiple languages and deal with that. But anyway.
Yeah.
All right. Well, so we're gonna have Dean Murphy on with us. He's gonna talk all about Crystal, and if you haven't already, go check it out. You can go to crystalapp.co, and he's got all the information there. And of course, if you just Google Crystal iOS, it'll come up as well. I purchased it, put it on my phone, and it works exceptionally well. I mean, it does the job, and he's selling it. I think he's selling it for like 99 cents. So it's kind of a no-brainer. All right, so I got one other announcement here before we get into our topics, and this one is Ed. This one's for you, and also for everybody on the panel, but it's addressed to you in the forums. Someone, Epicurious 101. I don't know if you saw this already, but he says I just wanted to quickly say thank you to Ed for the sheer amount of work that must be going into all of these game making tutorials. As someone who is pretty new to Corona, they have massively helped me to organize my thinking around how to put a project together. I recently found myself stranded from my computer for a week. I don't know if I can even imagine that, but able to watch YouTube videos. And I've been hoovering up this series and the Zigzag Boom series. Great work, guys. So, Ed, thanks for all the hard work.
I saw it and I haven't responded yet because I'm not too good at responding to.
Yeah, right. Yeah, you don't take compliments very well, do you?
I haven't got a problem. I'm not good at taking compliments. Never have been.
That's all right. So a lot of people aren't. You know what? In those situations, what I've learned to do is just say, "Thank you."
I'll just leave it at that.
And just leave it at that. And that's usually all it's required.
Hoovering tells me that this person sounds like they may be British.
British, yeah. So I did this. I did the same thing. I was like, "What's hovering? He's hoovering. Oh, he's hoovering. He's sucking up the information." Oh, okay, got it.
It's really funny because I thought Hoover was like an old style. If you think about it, right?
Yeah.
Go with the nomenclature. Isn't that like the old American vacuum cleaner, Hoover?
Yeah. But I don't know that it wasn't international. I mean,
that could have been.
Yeah. I mean, you think about it. Back in the day, that would have been your market, right? You would have been Australia and Britain and the U.S. I mean, English-speaking markets would have been certainly a prime target for you. So,
Hoovering.
Hoovering. Yeah.
Hoovering indeed.
All right. Well, hey, we got Kevin with us. Thanks for joining us, Kevin.
All right, got here just in time. All right, show's over, Kevin.
All right. Yeah. All right. Join us next week when we'll. Okay. Well, like I said before, we talked about vector math last time.
Mm-hmm.
What do you want to do this time?
Well, what I want to do this time is I want to go through it step by step, and first I'm going to show people what's new in the project. I'm just going to show them the features so that they know they're there, but we're not going to. We may have time to go over them at the very end, but then what I want to do is switch over and break down an example of how we calculate, how we determine where to aim and how to fire and how to create velocity vectors and all that good stuff. And then what we'll do is we'll take that example, which is about 15 or 20 lines of code, if I remember correctly, and then we will live change it to create a homing projectile, as we've gotten the nomenclature correct now. Thank you, Sergey. I get that wrong all the time, and that's, I have to say, actually, I should correct myself and be careful because I'd hate it when people use the wrong term for something, and here I am, I was using the wrong term. So, what we've got in the current game is, I can't remember if we said this in the last show or if this was something that you and I bandied about in, I think we talked about it on, what is it called? Slack. But I can't remember now. Whatever the case was, is you said something about heat-seeking missiles, and I just thought that sounded so good, I thought, yeah, that's a good idea. So what I added, what you're seeing now on the screen, is the same game as always, but you're going to notice that there is a new HUD at the top.
We still see you.
Oh, yeah. You're not. Yeah, what you're seeing is me talking to my screen. Bada boom, bada bing.
Yeah, I remember that conversation. It was in Slack, and I had used the term heat-seeking missiles, and you had interpreted that as being able to throw out decoys to keep from being hit.
Exactly. So that's what I have implemented as an additional feature. And just to walk you through what was required to do that was I duplicated the code in Game Lua for the coin HUD. If you remember, there's a HUD in the coin. There's a coin HUD in Game Lua, which basically looks at the level it's about to load and says how many coins are in that level. Make a HUD showing how many coins you need to pick up, and then as you pick them up, the coin counter fills in. It turns the other color so you know you got it. So I duplicated that for what I'm calling decoys. So for every decoy in the level, you'll see one of these little markers up here. Let me go with a bigger screen here. Sorry.
So you can have multiple decoys.
Yeah, you can have multiple decoys in a level. I'm only showing one in this current level.
Gotcha.
Because I'm actually still game balancing it. I don't feel like it's quite right yet. I also needed to add a button to throw the decoy out or fire it or do something with it. So in inputs.lua, I added a new button piece of code, and in game Lua, I added a listener for it, and in player The player builder, I added a listener for it so that the player would do something when it heard you throwing out the decoy. Now the reason there is a listener in game is so that we can update the HUD. So when you throw out one of your things, it takes one off of the HUD. So it's a little different from coins because you can pick it up and it gets filled in, but then when you throw it, it's gone and it's no longer in your inventory, so you get a blank again. So if you imagine if there were like 3 of these, you could see, oh, I picked up 2, there's 1 left to pick up, then I fire, and then I only got 1 left. So that way you know you're out. So then I added a new builder for these, which is very much like the coin pickup. Its whole job is that when you, let me reload this, when you run around and you encounter, I'm going to get killed. Ugh. When you encounter it, when you collide with it, okay, stop it. Yeah, that's the problem with demoing and having a turret that's trying to kill you. That it picks it up and puts it in your inventory. Then I also added a small piece of code that's similar to the jump code. So when we hit the jump button, it applies an impulse to the player straight out from the current gravity source. What I did was I said when you click this button or you hit the space bar, it creates a graphic for this, adds a body to it, and then gives it a little kick right from the center of the player out here. And it's got a little bit of linear damping, and it's got no angular damping, and then it's got an angular velocity of 90 degrees per second. So in other words, what happens here is you give it a little kick, and then it immediately starts to slow down and eventually stops at some distance, wherever you're pointing, and then it just continues to rotate. So it's got a little visual element so you can kind of see it there. Then the way these things work is I went back and I modified the turret code, and I'll give you a chance to take a look at that after I go through the fundamentals of vector math here for creating turrets and stuff, which we're going to do next. But I added, okay, first of all, I'm still using the action library, which is going to be released in a plugin in a week or 2. I've released 2 plugins so far that are going to be incorporated in this project. One is the collision calculator that makes doing collisions easy by using text instead of numbers or math. And then the vector library, which we're going to see in action today, has been released and slightly modified to make it a little bit easier for folks. And so I'll be incorporating that in the project too before I commit this version. But again, as I was saying, the most complicated thing we're doing in the game so far is the homing missiles. So I don't like to write that code by hand, although we'll do it together today one time so I can show you the basic version. And the reason is because it's easy to do a homing missile that immediately aims in the direction it's supposed to be going. But when you want it to aim at a certain rate and turn slowly, then it starts to get a little more complicated in terms of managing that and make it easy. So I have a library that does all of these things. It's called the Action Library. It's currently part of SSK. And as I said, I'll be releasing it as a plugin, as a separate plugin, so that people can take advantage of this and do one line code like I do instead of doing multiple lines. Although I think doing it the first couple times yourself is probably better so you get the concept. But there's all kinds of little weird tricks. Like, for example, when it fires here. Oh, what the heck was that? I just lost it. Let's try that again. One thing that's really kind of interesting is when you do a homing missile using what I call a naive approach, which we're going to see here in a little bit. Basically what you do is you say, I need to aim this, I need to turn this thing so it's facing the target. So you can do this one way, which is say, just immediately face the target. So it would very abruptly change direction and face the target, which is good in some cases, but it doesn't give you this nice curved path like we're seeing here. So it's turning slowly. So then you say, okay, I can deal with that. And you add some enter frame code, and you say, I can only turn 5 degrees per second or something like that. And you do the math, and you think you've got it all working. And then you start playing, and then about, I would say probably like an hour later, goofing around with your code, you're playing your game, you're having a good time, you go, hey, wait a minute. You'll notice that sometimes the projectile takes the long turn, which is it only needs to go 15 degrees to the left, but because you used a naive approach, which is just thinking in terms of 360 degrees, instead of turning left, your calculation, almost certainly, I guarantee you, the first time you do it, will always be rightward. And so it will turn 360 degrees around and take a big loop. And you say, okay. And then you'll puzzle over that for a while. If you've never encountered it, maybe a half an hour later, you'll finally go, oh, okay, I need to split that down the middle, 180 degrees. I need to decide, is the shortest path left or the shortest path right? And you figure it out, and it's all done. Barry's here. So anyways, the point is that the reason I have the action library is so I don't have to remember that stuff, because it is, in fact, quite painful for me to remember that little trick, which is the split it down the middle, decide which of the 180-degree turns is shorter. All right, so just describing what we put in this. So when I commit this later today, this is the code that's going to be in here, and level 7 is demonstrating the decoy, and I'll just show you what it does. Let's go get our decoy. There's one little bit of code that I added here. Let me pause that. Another thing that comes with the action library is for the homing features, which they're not. It's aiming and stuff like that. It has some debug code so you can see where the target, whatever it is that's aiming is trying to go. So this line represents the target, the current target that is trying to seek. And then there's another little bit of code that you can add. It's a one-liner that says, how many more degrees do I have to turn before I'm directly dead on? So if we keep pausing this, you can see now we only got 29 degrees to go, 16 degrees, and now we're dead on at 0 degrees, aiming directly at the target that we will obliterate in 167 pixels. So the D is how many pixels away is it in design space. So what does the decoy do? The decoy, the way this works, still playing with this a little bit to balance it. Now, one of the problems with doing a feature like this is you put features in, and then they can completely unbalance the gameplay, or they can be completely useless. And right now, this one is feeling a little bit useless to me. It works, and what it does is you fire it off, and then if the turret fires a projectile, a missile, rocket, whatever you want to call it, it's going to search for something nearby, and it will always search first for any decoys. So it prefers decoys to the player. That's the way I wrote the algorithm. So first it looks through the decoys list if there's any out there, and it says, are any of these decoys close enough? Let me find the closest decoy, and that's going to be my target. And then it homes in on the decoy and ignores the player. Now, if it has already locked onto the player, and I fire the decoy, the game's up. It completely ignores the decoy, and it's going to home in and get the player. Now, this is what feels a little bit useless to me. What I was really thinking about doing is allowing you to fire that decoy, and the missile or rocket would say, oh, decoy, let's go for that. Because that kind of seems more defensive to me, strategically. And the reason I feel like that's better, and you guys could tell me maybe, maybe not, is there's a limited range in which you have an opportunity to do something. This thing doesn't detect you until you're very close, and then it fires. And then if it immediately locks on you, having that decoy is almost useless, because you almost have to like run around and fire it and then run away. And that's great, but by the time it locks in on the decoy and you've come back around, it's too late to take advantage of that sort of like safety time. So what I mean is, I'll demonstrate this. So we have this, it fires at me, immediately sees me, and I gotta run over here, and I go, oh, fire, and it's too late, and I'm like, oh, okay, now I can, oops. Still got killed for some reason. Good job. All right. But the point was, is this thing fires so frequently? Let me get somewhere. I'm not very good at playing my own game.
Nice.
Oh, of course, the best place to hide from, I have to tell you, the secret here is right there. Not going to get me. Doesn't have the turning radius to get me.
Just outside of his vision.
So, but the point is that the oh, I didn't pick up a decoy. Good job. Ah. Ah. Oh, okay. Obviously not good at my own game. So there's some balancing issues with the decoys. Maybe I should shoot them out further, which would give you better placement, because basically you have to aim where you want it to place, and by the time you can aim where you need it, you've already been detected.
Yeah.
So
I see that
the idea of like deviating and going after the decoy immediately is probably better.
I see that the like you said, when you deploy the decoy, it comes straight off the player, only goes a certain distance from the player, right? So yeah. So it seems like it would be good if you were kind of like if you were running around the platform and you deployed the decoy,
or like dropped.
If it would continue to kind of drift around the platform, you know what I'm saying? Like it's like it kind of slides across.
It could like run around the platform or have a little bit of continued momentum.
Yeah.
Have gravity or whatever if it was close enough.
Yeah.
I don't know. This is one of those things when it comes to game design where you're like, it sounded good, but then it's not really helping me a lot. And then you got to experiment a lot with this and try to make it work.
Or maybe if you were running, maybe the decoy doesn't deploy all the way out. Like if you're running, the decoy only deploys like a certain distance or something. But if you're stopped and you deploy, then you deploy the decoy all the way out to its fullest extent. Does that make sense? That way, if you're running and you deploy the decoy trails behind you, and then the
but if you're stopped, then it fires out.
Yeah.
I see what you're saying. Yeah, you could drop it while you're moving at a certain velocity.
Yeah.
So yeah, while you're jumping, or if you're running around, it would drop. Oh wait, or you can just get killed. Well, it helps if you have a decoy. But then then you fire it out.
Yeah.
I getcha. Yeah, could be. I'll play with it. Anyways, I'll consider some other options. I'm going to commit what we've got today, and then puzzle through it a little bit more.
Okay. But I can definitely see what you're saying, though, because here's a feature that's been added. It serves a specific purpose, but it doesn't feel.
Yeah, it doesn't feel like
finished.
It's helping me a lot.
Yeah.
So,
right.
Yeah. I would say it needs to definitely have the missile track it as soon as you drop it. But the other thing is, how often does the rocket launcher fire missiles? Maybe a decoy could survive for more than one missile to give you a bigger window. That would help.
Yeah, that's a good idea. Could also, I wasn't sure about whether the decoys should have infinite life or limited life. So yeah, that's a good question too. So decoys, I definitely think that decoys should immediately attract whatever missiles are in the neighborhood. Because you can get into scenarios you got more than one following you, and they should all go for the decoy, the nearest decoy.
Well, on the initial deploy, like when you first come across decoys, it would make sense that they would have sort of an infinite life, and then as you progress and become more accustomed to using decoys, then now to increase the complexity, you have them have a limited life, right?
Well,
so they
adding even more complexity to the game.
Yeah, sorry.
Yeah, now we're gonna have to introduce help that tells you how to play. Because now your decoys don't last as long.
Well, I wouldn't think so. I mean, I would think in the beginning your decoy would just last, right? Because it's a kind of a new thing, and you're like, okay, cool, I can do these decoys. And then the first time you use it and it's limited life, then you would kind of get that. What happened? Oh, my decoys aren't lasting as long now, and you just kind of intuitively get it.
Yeah, or you could give like a couple different kind of decoy art. This art that I'm doing here is real basic, but you could have like an art that sort of implies that the decoy's got unlimited life.
Gotcha.
Or it's like hardened or something.
Yeah.
So anyways, this is the point where I would not take this game much further, because then you have to start exploring the art, which says a lot about what's going on. Because you want to give people a clue. Either got to tell them or give them some kind of clue. I agree with what you're saying in terms of like you can have two different kinds of decoys. But if people don't realize how it's going to behave, they would get frustrated. They're like, I don't know if this decoy is going to protect me for 3 hits or forever.
Right. Oh, yeah. Right. I see. They need some sort of visual signal or some sort of way to know.
Feedback, so they're not like confused. Okay. All right, I'm gonna get cruising on this next thing here. So we can get through this. I want to help people understand what's going on with vector math as far as like aiming and tracking and doing all that kind of stuff. So the demo that I'm showing you here is going to be in a subfolder of the project They Need to Be Fed, and it's going to be under vector math samples. And currently there's a project under here called Simple Projectile, which we're looking at. And then given that we have enough time, which I think we will, we're going to duplicate this, and together we are going to add a projectile that hums. Currently, we're going to add a projectile to this turret that we see turning back and forth that simply fires. So I've already written part of the code that I can walk through, and then we'll write together the next part that fires the projectile, and then we'll switch it over and we'll create a copy and make that projectile homing so that it keeps trying to hit this as it goes by.
And just to make sure, and I know you probably just said this, but we are isolating a specific piece of the game so that we can focus in on the details of how it works.
Right. I wanted to take this completely out of the context of the game so that I can, what this allows me to do is not only show you everything in one place, but it also lets me ignore some of the things that I did in the game. Mm-hmm. You'll notice that in the piece I'm going to show you here, there's no safety code. There's no code that says, does the object still exist? Is the game still running? No, this is a very naive approach. It just assumes like things are going to run forever. So it's a one-file example. If we ignore build settings and config Lua, which are sort of, they always come along for the ride, and we just focus on the code. All the code for this example is in a file main Lua. Let me make it a little bit bigger so you can read it. The first thing is it uses the Math2D plugin, which I released last week. You can get this. You can get the documentation by going to the store page and clicking on the Math2D plugin page and the docs link from there. And I'll share a link with Charles for the show just to point people in the right direction to this. But you just simply require it like you would normally would. Require plugin Math2D, and you need to have a little statement in build settings that says, I want to use the plugin. All of that stuff's in the documentation you can find on my site from the link. It's quite straightforward. Up here at the top, just for ease of use, I've created two variables, CX and CY, which stand for the center X and center Y of the screen, because I don't like typing display content center X every time I want to put something in the center of the screen. I've also forward declared three functions: move target left, move target right, and shoot. Now, move target left and right, their job is to move the green dot, which is our target, from the right side of the screen to the left side of the screen to the right side of the screen, just back and forth. And what they are, first of all, the target is nothing more than a circle placed 200 pixels to the right of the center of the screen and 100 pixels above the center. So it's initially placed right over here before it starts running. And then I change the color to green, so that code's very, very straightforward. And then I have these two functions, which I forward declared, and I'll tell you why in a moment. And inside of each of them is simply a transition function. And the transition says whatever object is passed in, make the X position to whatever I'm supposed to. So the center of the screen minus 200 pixels or plus 200 pixels. So the right side or the left side, or actually that would be the left or the right side. It takes 8,000 milliseconds, 8 seconds, to transition from one point on the screen to the next. And the onComplete callback, the listener, is simply the opposite direction function. And this is why I had to forward declare these. I basically created a local variable, but I didn't have anything assigned to it yet. I'm just saying, hey, look, this exists. And that way I can reference it when I when I define my function, so that later this code will know, oh, move target right, well, that's this function that got defined a little bit later. So it knows how to find the code.
That's quite a good tip, Pat. I've never realized you could actually do this.
Yeah, I encourage people always to consider forward declaring if they're not doing this in a module.
Yeah.
Sergey and I had this talk sometime back. And another thing you can do is if we were doing this in a module, say like local public equals, where public is just some table, You could also simply just do this, public dot, public dot, dot, and then public dot, public dot. This will also late reference this whatever's going to be put in that variable.
Right.
So all this is telling Lua is saying, hey, I'm going to put something there. There's nothing in it yet, but by the time you get here the first time, it'll be filled in.
Yeah.
So it just otherwise people get into this chicken or egg scenario where they're like, I want to have a function called function, but how do I make it work?
Yeah.
I see this all the time. People are like, I can't do it. Yes, you can. It's very easy.
It's a good tip. Anyway.
All right. Well, thank you. I appreciate that. And then I call it.
I'm a fan of the table method. Because then you can add things as you go. You don't have to go back and check that you've done something, because what can sometimes happen is if you forget to declare the local, then you've created a global. And it may work, but you've got this global function lurking around to cause problems later on. So the public table is really good. It also means you can have two tables for functions, a public one and a private one, which gives
Right.
security.
I don't do that very often, but it's something that I would encourage people to do who want to. So they're trying to use modules to sort of have an object-oriented or a encapsulated approach, and you can create a public table. So what Barry was saying is what I just did there a minute ago. Oops, that's not it. So I created this local public table, and then I would attach functions to this and return public at the end of my file. Ugh, if one could type. Let's not return that. I return public at the end of my file. But what if I wanted to have some like private functions? So everything attached to public is now visible outside of the module. But if you're like a C programmer, or not C, a C++ programmer, you go, I want private. Well, sure. Okay, there you go. Private. Equals. Boom. Add some more functions in here. Use them off of private, but never return it. Never show this to the outside world. So that's a nice way to sort of split things up. I usually do this by having local functions that are forward declared, but this is another perfectly valid way to do it. Let me get this all out of here now before I totally mess it up. All right. All right, we got 15 minutes. I can do it. Boom. Shoot. All right. So anyways, I call move target left to start the ball rolling, and it moves the green dot to the left, and when it gets to the end here, it will call move target right eventually. Dun, 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 and it'll start moving to the right. So now we have a moving target. Now I'm not going to give this thing a body because I don't actually want to hit it. All I want to have is something to aim at. So let's create a turret. First of all, when I say a turret, what I really mean is like a turret base. This circle here, this yellow circle, is going to act as a visual representation of where my gun is, my cannon, whatever you want to call it, my turret. And this blue box is supposed to visually represent the barrel. So it's just to give you this nice, oh, it looks kind of like a gun. My brain can deal with that. It's a gun. It's a weapon of some sort. The way I do that is I say local turret, and I create a circle. I place it in the center of the screen, and 100 pixels below the horizontal or the vertical center of the screen. So right here. I set the fill color to 0000. In other words, I make it invisible. I give it a stroke color of 11, which is yellow. I change the stroke width to 2, so it will clearly show up in our example here. If I made it 1 in the simulator, you may not be able to see it at certain resolutions. So I just want to make sure you can see it clearly. And then I do a little tricky thing. I create a barrel, which I place at the same position as the turret, wherever I just placed it. I make it 20 pixels wide, 50 pixels tall. I also make it transparent, or has no fill. And then I give it a stroke color of 011, which is cyan, sort of off blue, if you like. I give it a stroke width of 2, again, so it shows up clearly. And then I do this little trick. If I didn't do this, what we would have is initially we had this, where the rectangle was centered on the circle, but I want it to look more like a barrel pointing out. So I use the anchor. I use the Y anchor, and I push it down. I basically say anchor it near the bottom of the rectangle, but not all the way at the bottom, so that it semi-overlaps the center. In other words, this would be all the way at the bottom. This is where the bottom of the rectangle is now aligned at the center of the circle, which, you know, that could look kind of okay, but I kind of liked it better where it was more like, I don't know, let's try 75 and see how that looks. 3/4 of the way down. Let's do that correctly. Load it. Yeah, that looks pretty good too. So now it's 3/4 of the way down. So really what we're anchoring is right here on the rectangle. Now the cool thing about this is anchors are really powerful in the sense that although I've sort of offset it, if I rotate it, it's now rotating about this virtual point. This is the center of the object as far as Corona is concerned. So as it rotates, it's rotating about that point. So it gives us this nice visual aesthetic doing exactly what I want it to do, which is rotating and pointing like a barrel. It's my poor man's barrel. Okay, so now into the meat of this. The meat of this, what's going on here is I've added an enter frame listener that is attached to the barrel, and what it does is every frame it says determine a point, a vector between the barrel center and the thing that I'm pointing at, and then rotate the barrel so that it's pointing in the same direction as that object. So to do that, we calculate the vector, and then we convert the vector into an angle, and then we change the rotation of our turret to be the same as that angle. We want our angle to be the same as the angle of the vector. So to do that, it's very simple. We use the Math2D library, and we use the diff function. Now diff is like subtraction. It's doing a subtraction, but what it's saying is it's saying subtract. If I had said this, right? This was a change that I made when I released the library to make it a little bit simpler for folks who maybe didn't read the documentation. I didn't want people to see this and assume that I was subtracting, I was doing this. This is what that implies. It's saying, if you read it straightforward, it says do a 2D subtraction, self minus target. That's just what the brain says. Now, to get the vector from here to here, what we really need to do is subtract the position of the turret from the target. It sounds kind of counterintuitive, but once you have understood how vector math works, what we're really trying to determine is the offset between here and here. And so if you think about it, what is the, if it stop moving around and make it a little bit simpler to visualize this, we want to know how far away this is from here, not this from there. So to get a distance, in a sense, it's always where we are to where we were. We want to go from here to here, so we have to subtract this position from this position, and that gives us an arrow, in a sense, pointing in the direction of the target. So long story short, we have a subtraction function in Math2D, and it operates left to right, self minus target. Or if this was argument A and this was argument B, what it's saying is subtract B from A. Just like you would expect for normal subtraction, left to right. However, the operation that we're doing today, which is trying to create a vector pointing from A to B, you do it all the time. This is like the #1 thing you do with vector math for action games and arcade games and stuff like that. You're always doing this. So I thought, why make it confusing? I will simply add another function called diff, which is the difference, which says the result of this is actually target minus self. But in my brain, I'm thinking, what I really want to do is I want to get the vector from self to target. So the vector from self to target is actually the position of target minus the position of self. I just want to be super clear about this. So people, when they do this, and if they try to use subtraction, you're going to get exactly the opposite result. You're going to get, if you did subtraction, you'd get a vector pointing from the target to the turret, which is not what you want. Okay, so given that we now have a vector, which this will return a table containing an x and a y value representing the direction and the distance between the turret and the target. We can simply take that and convert it into an angle by calling math2d vector to angle, which takes a vector argument and converts it into an angle between 0 and 360 degrees. Well, 360 degrees minus some small number, not inclusive. Now that we have that angle, all we have to do is rotate the turret to be the same angle as that vector. So this vector is now like 45 degrees. So the rotation of our turret will be 45 degrees. And as we run this imaginary arrow that we have here is going to change the angle that it is from the center, and all we want to do is just keep changing the turret. So 3 lines of code, and now we have a turret that tracks our object, our target. So what's left to do? Well, I added a little piece of code here just so people could see it that further visualizes the pointing. So what I'm doing here is every frame I'm creating a line, and then the next frame I'll delete it and replace it with a new line, and that line points from the center of our turret, and it uses the vector, you'll see. Basically it says start at the turret position and then add that vector that we got up here, vector x plus my current position x, vector y plus my current position y, to prove that this does in fact create an offset that points in the direction that we want to go. So let's go ahead and flash past this. So now that's all that's left. This is all the job of the enter frame listener at this point to do, is it needs to point us in the right direction. To fire, what we're going to do is we're going to create an infinite timer. So we have a timer perform with delay every second, and then we have a closure, and inside that closure it calls shoot, which we forward declared at the top. We haven't created an object or a body for it yet, and we're going to pass in the barrel, and I'll tell you in a moment why, and end, and then -1. So basically what this is saying is every second shoot and pass in the barrel. Now the reason we're passing in the barrel is because I want to do is every time that function executes, I want to create an object here at the same position as the barrel center, and then I want to fling it off in the direction that the barrel is pointing. So let's do that together. First, let's go ahead and create the circle. Let me just steal some code here. Call it a bullet. Actually, I'm going to use temp, TMP. I use this a lot in my code because it's short to type. And we'll take the position of the turret, object X, object Y, and this is a circle call, so we'll give it a small radius of 10, so that'll make it 20 pixels wide. And let's make it red so we can see it. And we'll run it and see what it does at that point. I cannot type. We're going to run that, and boom, we got a red dot. I pause it. So there's our quote-unquote bullet. So let's do the next thing. Let's give the bullet a body, because we need to give it a body so we can use physics to start moving it. And I just realized I didn't require physics. So let me require physics. 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 Wow. I'm so bad at typing. Okay, physics, start, physics, set gravity, 0, 0. I'm going to have the gravity be 0, 0 because I don't want gravity to move our bullet. I just want it to, I want to use physics to be able to apply a force or an impulse to our bullet to move it. Okay, now let's go ahead and say physics add body temp, and think for a moment. We don't have to do anything else. That will apply a dynamic body to it, and I don't care about any of the other parameters. Physics. And the only thing I want is, actually I don't need to do anything else because I'm not adding bodies to any of the other objects here. Again, all I want the body for is so that I have some way to move this object other than using a transition. Physics. Now let's see if I did anything stupid and crashed the thing. Yeah, I can't type. 5 physics. Proving once again that I cannot type. Reload. All right, good. Okay, so again, okay, stop it. we got these bullets here. Well, it doesn't want them to overlap. So what happens there is it says, hey, this is on top of the other thing. Push it somewhere. So it pushes it in some random direction. Now we want to give it a little kick in the direction that the barrel is facing. So let's get the angle. Let's get a vector representing the direction the barrel is pointing. Let's leave this here. And let's say local vec equals. We already did this once, so we'll just steal the code up here. Right here, it's going to be the same as the code previously. So now this will give us a vector that is pointing from the turret to the target, but it's got a problem. This vector is as long as this point to this point. Now, what we want to do is we want to give the projectile a certain velocity, but we want to be able to control that. So in order to do that, we have to convert this vector into what's called a unit length vector, which is sort of like the workhorse of vectors. A vector that is of unit length can be used for a number of very interesting calculations because it has this property that says it's 1 in length. So it basically represents a direction, but no magnitude. The magnitude is, in a sense, how long the vector is or how much force it represents. So 1 is the magic number that you can use and convert it into whatever you need it to be. 20 pixels long, 200 pixels long. Without the unit vector, vectors would not be very useful in terms of like calculating forces, etc. So what we'll do is we'll get a unit length vector. We'll convert it into a vector of length 1, which is called normalizing. So we'll say vec equals math2d normalize vec. So I pass the vector here into math2d normalize. It does some magic, does a few calculations, and it returns a new vector, which I'll just store in the same variable. And this one is pointing in the same direction as our initial vector, but now it's only 1 pixel long. So if I were to draw it, you wouldn't even be able to see it. It'd just be a dot on the screen. And when I say pixel, because my calculations are in screen space, so if I were to draw it, represent it visually, it would be whatever my screen space is. So 1 or 2 pixels, whatever it's being converted to for this current scaling of the screen. Okay, so now we've got a vector that points in the direction we want to kick our bullet. So if we have to decide, do we want to give it a kick, which is an impulse, or do we want to give it a fixed velocity? And I'm going to say fixed velocity because it's easier to express for this scenario, but a kick is also good. It depends on how you want to make your weapon behave. And I think that in this case, just giving it a fixed velocity is much easier to sort of grok, understand. So to do that, we need to convert this vector into a velocity vector, which says what direction is it going to move in and how fast. To do that, we say vec equals math2d scale vec, and then how long we want it to be. So let's say I want it to move at 150 pixels per second. I will simply make this vector 150 pixels in length, or the concept, again, in screen space. I'm waving my hands at the screen. I do this all the time. I wish there was a camera. You could get so much more out of this with me waving at the screen. So again, scale the vector, make it the length that I pass in here, and I always get these backwards. I can't remember I put the scale in the front or the after. Let's see. Okay, good. It's after. And it is diff self-target. Oh, look at me. I use the term object here, so I got to put that there. That's sorry. So between object and target, and let's reload it. And okay, good. So at this point, now we have a velocity vector. So what do we do with it? Well, we apply it. We say object set linear velocity right out of our tool. Right out of our Corona toolkit, and we say vec x, vec y. That takes this vector that we calculated, we pointed it in the right direction, and we gave it a certain length, and now we're going to say that is your velocity, go. What we should see is when this runs, the bullet should take off, if I didn't mess up, should take off in the direction the target was at the time that it was pointing at it, which is the weakness of this, because the target will keep moving. Boom! Alright, set linear velocity. Oh, idiot. Sorry. Temp. That works better. Apply it to our bullet. Okay, we're firing and we are totally missing. Okay, so we're over time, but in the next 5 minutes we can fix this problem and always hit it. So let's do that. Let's change this example to make that bullet always go and smack that baby. Or at least cross it, because there's no body, it's not actually going to do anything. So I'm going to copy the project. I'm going to call this one homing. Thank you, Sergey. Projectile. Give them props, because props are due. And let's get this code out of here. Let's go ahead and load up this project. Homing projectile. It's going to do the same thing as our current one. So let's make it homing. The homing is saying, all right, cool. So it's got an initial velocity of whatever. I'm going to make it a little bit slower just for fun because I wanted to give it time to home. So I'm going to make it like 50, first of all. Now the bullets are going to come out, and they're going to be super slow. So what we need to do is we need to say every frame, you look at the target, determine a vector between yourself and the target, turn yourself, and move in that direction. So let's go ahead and add a function. I'm just going to put it right here for now, called steer. And then I'm going to say temp inner frame equals steer. Runtime add event listener frame, enter frame. You guys are probably just having a good old time with me not being able to type here. And then let's go ahead and say steer equals function self. And let's not fill it in yet. Let's just make sure that I always do this. So I put in the framework and just run it to make sure I didn't goof up. And I did. What did I goof up? 83. Run time add event listener. What did I mess up? Oh, idiot. That's how I code all day long. I constantly call myself an idiot all day long as I'm coding. That's letting you guys in a little secret there. Okay, I got 3 minutes left. Okay, so it's the same thing over and over. I mean, this is what I mean. You do this all the time. I mean, this is a little bit wasteful. The good thing to note is that the Math2D library comes with what is called a flexible variant of these, which is the one I'm using now. This flexible variant of these functions takes objects, and it also takes scalar values. So if you wanted to put the x and the y of the object and the x and the y, so 4 arguments, x1, y1, x2, y2, you could do that. And this function would recognize that you had changed the pattern of the signature of the function call, and it would do the right thing and say, oh, okay, you're passing me scalar values, numbers, versus a vector, an object, that encapsulates that information. Now, there's also a fast version of this incorporated in here, which is simply fast if, and it only takes scalar values. So it's less flexible, but it's as fast as possible. So this one will execute significantly faster than the flexible version, but depending on your usage, you may not care. It may not make a difference to your game. If you find you're using the Math2D library and part of your game is kind of slow, consider moving over to the fast version, and then if that doesn't work, then you need to break down that specific calculation and hand code it at the location you're doing it so that it's fast as possible. In other words, don't use my library, but actually do the vector math yourself, and that will be the fastest possible implementation of that calculation. So I'm just going to show this to you. Actually, you know what? I don't like these. I like the flexible versions so much more because they're smart in that if I pass 2 objects, they return an object. If I pass 4 numbers, they return 2 numbers because they say, well, that must be what you're thinking. And you can also tell them, no, I want you to take 2 objects, but I want you to return 2 numbers. So if you put the last argument to all the flexible ones as true, it returns the opposite of whatever you passed in. So if you pass in objects, you get 2 numbers. If you pass in 4 numbers for this particular call, you get an object or a table. So it's like very, as I called it, flexible. You can see this in the docs. It'll be a little bit more clear. Okay, so again, we want to steer this projectile in the direction of our target. So we need to know what that direction is. And the cheapest, simplest way to do this is simply to continually change the velocity of our object so that it's always moving in the direction that it thinks it needs to go. In other words, where the vector is pointing. So this thing that we just did here, let's just do it all again. We just take this, copy it down here, and I have the self argument here, so let's say self and self. And we'll keep it at the same velocity just for fun. And run it again. Boom, chakalaka. And now they're coming after it. Now, it's probably going to break down when it hits it, because it's never going to remove those projectiles. So that's a little goofy. But the point is at this point you can really see that it is in fact steering in the direction. Now let's make this significantly faster. Let's make this 150. 150, and let's make it only fire every 3 seconds, and so we don't get too many of these out here, and let's see what happens. Boom. Easy peasy. A naive approach to a homing projectile done in 4 lines of code. Yeah, 6 if you count these 2. Okay, 7 if you count the forward declaration. So, but the good news is if you don't like to type 7 lines of code, you could require the action library, and in 1 line of code, you would get the whole shebang, and you could even tell it how fast to steer. So, like, you could give it only steer at 90 degrees per second. So you can't steer that quickly, and you're lagging eventually, or depending on how fast your target's moving, you may lag it and have to turn one way and turn the other. You get cool little behaviors like our trails, which is what we do in our current game.
Well, this is great. I think this is a great example. Like you said, isolated from the game itself, so we can understand the different concepts.
Yes, I do hope that was a little more tractable. I think that people will watch this the first time and don't feel bad if you're like, oh, it's still too fast. Just watch it one time, look at the code, go down and sort of like break it down the way I did, step by step, and see what comes out. You can go in here and print out the values that come out in the tables that are returned, and print those every frame, and you can kind of see what's happening. So, but not having to worry about all the other game going on and like breaking it, I think that'll make it easier for people to follow up on this.
Okay. Cool. So now, the action library, you said that's going to be available, or is available, or what was it?
The action library is currently in SSK, and if you want to look at it now, it's actually in the project. You just go into the SSK folder, and there's a folder under there called Actions, and it has a bunch of subscripts like move physics, move, I can't remember the names, but it's got all kinds of stuff for moving, using physics, not using physics, aiming, acquiring targets, etc., etc.
Okay. All right, and then we'll link to everything in the show notes.
Yeah, I didn't want to go too much into what's in there until I get the plugin release, because it's really hard for me to talk to it without documentation for people.
Oh, okay, and that's where I was thinking about, is that last time you had mentioned that you're turning it into a plugin.
Yeah, it's just, it's done. It's just, writing the documentation is fun.
Right.
Fun.
Right. Okay.
I can't use Sergey's trick, which is just have one or two features on my plugins. That's all I have to document. Thanks for the advice, Sergey, but I just can't do it, dang it.
Just release 50 plugins, Ed.
Yeah, there we go. One for aiming, one for steering, one for moving forward. Oh my gosh.
Well, you could have a plugin system for your the action library, right? The action library is like the core, and then you have plugins that plug into that.
There we go. I could do that for bonus dollars.
Yeah, exactly. Okay, well, cool. This is a great example. Thanks for putting all that together. So, where do you think we should go next? I know we talked about this a little bit before the show started.
We had a little chit-chat before the show. Okay, so here's what I'm going to float. I think that next week should be the last episode on this game for a while, and what I would like to do is completely switch gears and convert from a fixed layout file method for creating the levels to a visual editor. So I will provide a visual editor, and I will demonstrate the fundamentals of how it's been. I'll show you where the code is and just give a quick walkthrough on the bits and pieces, and then show how to use it. And the reason I want to stop there is, and you can see me waving at the camera now, the reason I want to stop there is because I'm kind of getting, not bored, but I'm getting to the point where I want to take this game into another direction. And the direction I want to take it in is retain everything we've got, but make it a scene-to-scene game where it's a platformer that goes from scene to scene, allows you to navigate back and forth between the scenes, and it adds elements of a pseudo-RPG. So you can meet characters and get dialogues and get quests to pick up things, and you'll have a, not all at once, but we'll have dialogues, basic quests, inventory items, and an inventory screen to see what you've got, and whatever else comes out of that as we go along. I can't even think of the things. But basically what I want to do is sort of turn this into a pseudo RPG / platformer, which is kind of the thing that I see a lot of people trying to do or have over time. And the questions come up. How do I do a dialogue system? How do I do an inventory? Et cetera, et cetera. How do I store what my character currently has between sessions?
Well, yeah, and then we kind of talked about this before, but yeah, making incremental changes at this point really isn't all that exciting. But going kind of and making some bigger changes, adding on these bigger elements, definitely sounds like something that would be interesting to look at and explore and see how the things are put together. So great. Let's definitely do that. I know there were some votes for visual editor in the forums and stuff, and on the YouTube the comments and stuff. So that'll be great. Now next time, like I said, we're going to have Dean Murphy on with us. So that'll be I think a good episode for us to kind of wrap up this leg of the game and have him on as a guest.
Kind of a high level overview.
Yeah, right, exactly, and then prep us for the whole next series, and we'll have this game as a base, as a foundation for all these new features going forward, which will be great. I think it's a whole lot better than starting all over again. I wanted to comment
on something Barry said here. Sorry, before we hang up. Barry
there's lots of chat comments.
He said something about he called it extrapolating, but what you were thinking, I'm thinking, is predictive aiming, right?
Yeah, you basically extrapolate the position of where the target would be, and you aim at that instead. That's all.
Okay. I have in SSK. I'm not sure if it's currently released in SSK. It may be in my private copy, but I have a helper function that does that for first order calculation. So a first order calculation is where there's nothing is changing over time. So like linear velocity only, no gravity, no other outside forces are changing the direction. I can put that in as a third example when I commit this, if you want that.
I'm not sure if it's necessarily relevant. I mean, extrapolating is difficult to do well, and it still won't hit the target all of the times. So I think probably what people would want is much more like what you did anyway. I just assumed wrongly what you were going to start doing. That was all.
Oh yeah, no, there was no way. It's very cool code, but it's like 50 to 100 lines of code to do that because it's calculus. So.
Yeah, no worries.
So what I heard though is
calculus.
So, yeah, exactly. Calculus 1. Get your books out, kids. So what I heard is that there is a Super Starter Kit Ed edition out there someplace.
Oh yeah,
The
there's the private version.
Nice, nice.
I don't release all my good stuff.
you
sounds really wrong.
You keep back the special marbles for yourself.
My secret sauce.
Yeah. Oh, that's fine too. Well, great. Well, we'll be back here next Monday, talk with Dean and wrap this portion of the game up. And until then, have a great week, guys, and happy coding.
Cheers.
Bye.
Well.